have this Dynaco ST-70 back on my bench. This was Chris's. I say was because he's decided he just wants to give it to me. He's just kind of done with it and just doesn't have the patience to, you know, get it all together. In my last encounter with this machine, I ascertained that there was a problem with the circuit board, specifically at this point here. The right channel on this ST-70 was not working. At the top half of the waveform on channel B there was cut off. I fixed it simply by pushing on this connection right here, which indicates I've got a cracked joint. So that's pretty cool. That's an easy fix. Yay! I had already switched to the tubes between channels, the output tubes anyway, to see whether it followed the tubes, and it did not. It was this connection right here. So quick reflowing, and it didn't fix it. Pushing on the joint still fixes it, but reflowing it alone did not. Well, that's great. So I, carefully resoldered all that. And now I can't even fix it by poking it with the stick. I even tried putting a jumper between here and here in case this trace is broken. Nada. And so I advised him to simply get a new circuit board and repopulate that circuit board, etc. And he did that. When it came to redoing all this wiring, he was just like, I don't want to deal with it. And you know what? I totally get it, because the wiring's a bit of a mess. It's not color-coded. The wiring's not as I would do it were I doing it. Yeah, it's not amazing. Well, what's not amazing specifically? Well, what's not amazing is the wiring's not color-coded. It seems a bit haphazard, which to some extent is inevitable. There's just wires got to go here, wires got to go there. To some extent, it should be a bit chaotic. Well, let me explain. When you're doing point-to-point wiring, the advantage that you have with point-to-point wiring is that you have a third dimension that can allow you to keep various signal wires farther apart, and you can use that third dimension also to allow them to cross one another at right angles. See, for example, right here, these wires are crossing at right angles to one another. And that's actually a good thing, because signal wires that are perpendicular to one another, if they're perfectly perpendicular, then they are invisible to one another. But inevitably it leads it to look kind of chaotic, because you got wires going everywhere rather than all nice and bundled up. And when I see bundled up wires, I kind of cringe, because that means those wires are all bunched next to each other and therefore trading signals more easily. It's the color coding. There's also the issue of heater wiring seems bad. So that's heater wiring right there in these big loops. You don't want big loops in heater wiring, because that's carrying AC, and you're just creating little antennas when you make big loops like that, and that's going to radiate. The wiring diagram in the manual just doesn't really make it clear that that's something you should avoid. So when I'm faced with this, I'm like, okay, there's two ways to do a thing, right? There's the easy way and the right way, generally. And the easy way would just be to, pull out all these wires and so on, smack in the new board, put the wires back in their places, and be done with it. And I could do that pretty quickly, but that would not really be the best way. The best way, the right way, would be to redo a lot of this heater wiring And just to, in general, make sure that the point-to-point wiring is done optimally. And I would also, in general, replace a lot of the old wires because A, because they're old and crusty, and B, because they're all the same color, and that just color coding things makes life easier. Makes it easier to figure out what's going on in here. Now, there's another thing I really don't like, and that is electrical tape. That's just a big no-no. There's no reason to use electrical tape, as far as I'm concerned, like ever in a machine like this. Why is it there? It's there because, geez, why the hell is it here? You know, I'm not even clear about that. So, new speaker terminals have been put on. Generally, you would expect the new speaker terminals to be these, you know, sort of 0 ohm and 8 ohm taps. We ought to be using the orange wire and the black wire, not the brown wire. Brown is the 4 ohm tap. So that's brown. Orange is the 8 ohm tap. That's this one that's just dangling. Yellow is the 16 ohm tap, and that's this one. And it's part of the feedback network. That's where the feedback is taken off. And so that's why this wire is connected to this wire. I don't like that. I don't like that one little bit, this sort of dangling connection here. I can see why it is that way, because without the several terminals that would have been here originally, you don't have a block to mount that to. Ideally, this would be connected to a terminal tab, you know, one of these type things. And what I may need to do then is simply put in another terminal strip. I could attach another terminal strip potentially to this bolt here, or even this bolt here. And of course, I don't know why the 4 ohm tap is being used here rather than the 8 ohm tap, so I want to fix that. So the speaker terminal wiring and feedback network wiring needs to be redone. This had been serviced before. There's a sticker on the base. There's a sticker on the base metal of a service shop. What they replaced, I don't know. You know, did they put in a new multi-cap, for example? I don't know. But in any case, I will check to see whether those capacitors are in spec or not. Okay, so past that, then there becomes a question of what would you do differently? And, you know, specifically, would you do things like star grounding rather than whatever grounding scheme has been done previously? So this would be our ground, or at least a ground. Typically back in the day, they would just ground to the chassis. It looks like there is actually some star grounding going on here, in that we've got a single sort of pair of lugs that are connected to the chassis here, and there are several wires coming in to that point. So this is a ground terminal. You can see right here there's a ground terminal as for the capacitor. And there's a very short wire connecting it to this lug here. It's not awful, but we have created a little ground loop here, or potentially. I mean, it's not awful, because this is connected to the chassis, this is connected to the chassis. They're near one another, so it's not terrible. It's probably not even bad. And I gotta just sort of look for where else is there ground. So what's connected to here? This, okay, that's going to my speaker terminal. That makes sense. This, which is going to the circuit board, so that's going to be the ground trace on the circuit board. Looking like there's just the one ground connection, which is, if true, is good. Let's see the other one here. We've got going to the power transformer. It's expected. This wire going over to signal here, and this wire, okay, so we've got another ground point over here on this terminal strip, And then that's connected over to here. So ground's a bit all over the place. You know, if I were doing this, it's not terrible, but ideally I would have separate, you know, if I've got a ground, sort of a point to which several things are connected, that's connected to ground over here, I would generally run these aligned from here all the way back to central ground. Now the other thing I would do, I would put signal ground on a spur off of power supply ground. Signal ground would be its own star, so you know, if it's my hand, signal ground would be here, and then, you know, power supply ground would be right here. We don't have a 3-prong modern style cord, we just have 2 prongs. And so, you know, typically I would put in a 3-pronger. We've got a separate fuse here. Looking for the death cap. Where's my death cap? That is, there should be like an X capacitor and a Y capacitor. I'm not seeing those. Those are usually conspicuous. I can't get these out. I think those are directly connected to these like 10 ohm resistors. There's separate holes for those on the new board. Yeah, see? And there's not separate holes on the old board. So I think those are simply the leads through, and that's why they don't have insulation on them. So those just need to be snipped. Yeah. Out with the old. That thing is, look how charred these. I don't like having tube sockets on circuit boards for that reason, among others. The other being that every time you put in a tube or take out a tube, you stress all these solder joints. So I think I will go back over this board a little bit with the iron and some solder, just because I see a couple of joints that aren't to my satisfaction. And you know, I see a couple, so you just give it a general going over.
It's the shining up above, and the moon up in the sky. Say you want it, tell her why.
heater wires and the feedback. Which brings us to the wiring over here. For some reason, brown is connected when orange should be, and this connection is rinky-dink as hell. And same over here. Relatively simple to add another terminal here. Just like so. On the other side, that's not going to fit on there easily. Well, time to see what's under the tape. Oof. Tape. Jesus, that's not even soldered. Fucking Christ. That's not how you do an electrical connection. Not even soldered together. The other end of this bolt is underneath the output transformer. Don't really like my chances here for undoing that bolt and having it be easily retightened, because you want to be able to get to the other side of the bolt. On the other hand, if I use the bolts that are holding in the output transformer, then that's no problem. I mean, it's what I'm going to have to do over here, so I can make it match by doing the same over here. Heaters rewired so that we minimize the size of loops radiating AC. Similarly over here. And twisted these a bit tighter here and here. Again, trying to make the loops smaller. I think I showed this. Redid those things, put in the new terminals, replaced these. So I looked in the Series 2 schematic, and in that schematic it specifies that these are 1 watt resistors. And these are 3 watt that I've put in there. This one is 6.8K, this one a 22K. Put in new ones of those. Those were not too close to spec. I haven't checked any of the other resistors. I don't think any of the values are so particularly important on those. I'm ready to die. Let's get up close and personal with the ST-70. Let me show you the old board first. Now, I've already removed a few components. I've removed the some of these big film capacitors. So that's the old board, and this is the new board in its place. And this is obviously not the stock board, because that's what this is, but it is in the stock circuit. That is, the circuit has not been changed by using this board. There are plenty of boards that one can get for the ST-70 that involve changing the circuit. But this is not that. All right, so what are the salient features here? Well, let's look at the tube complement. All right, we've got 7199s. A 7199 is a pentode and a triode in the same tube. The pentode gives you lots of gain, so the pentode half is used in the gain stage, The triode doesn't necessarily give you very much gain, but it isn't needed. In fact, it's used in a circuit that gives unity gain, that is, no gain. It's simply used as a phase splitter. And then we've got EL34s in the output stage. These are pentodes. You might notice that these are different from these. These are new Pavane Horizon EL34-AT tubes. And these are, I don't know who made these because there are like no markings on them, but these are old EL34s. These were on the Heathkit AA40 that I got when I got it. So that's where I got these EL34s. There was a third, but the glass was broken. Here's our rectifier tube. The rectifier tube is essentially two diodes, but with a bigger drop. Diode drop is like, 0.6, 0.7 volts. This will drop tens of volts. This is a 5AR4. And this particular one is a tongue saw. Chris gave me this amplifier. He kept his own EL34s, which is why I've got 4 of mine in here. So this is the 5AR4 that was with the amp, and these are the 7199s. If there's a problem with this amp, or say a logistical problem, it is these 7199s. They're very expensive. They are not made anymore. So that's kind of an issue. So one of the mods that people will do, and in fact the series 2 and 3 of this amp use different tubes that are easier to get and maybe even have new manufacture. Here we have the output transformers. Output transformers are very important for the sound of an amp, of a tube amp, because all the sound has to go through these before it gets to the outputs here. Here's the power transformer. These are to set the bias. So this does have fixed bias, which is another way of saying grid bias. That means it has a negative voltage power supply, and the voltage on that is controlled, fine-tuned with these. So I've taken the tubes out so I can turn this over and we can look inside. But before we do that, I want to point out another thing that I don't like about this amp, and that is, well, I just don't like using a circuit board on a tube amp. I think you can get better sound with point-to-point wiring. Obviously, circuit boards aren't terrible. They're used in everything, but yeah, I'd rather not have one at all. And especially, I'd rather not have a circuit board to which tube sockets are mounted, because tubes have to fit in these sockets very securely. That means getting them out, you really gotta, and these are only held in place with solder joints on the circuit board. Solder joints can crack. Every time you put a tube in or remove it, you run the risk of cracking one of those solder joints. So I don't like that practice in particular of having tubes mounted to the printed circuit board, or PCB. Oh, one more thing on the top. This is the multi-cap, and we can actually tilt it up and look. It says what's in it here. I'm confused. As far as I know, these are supposed to be 40, 20, 20. Maybe that really is a range of tolerance. All right, well, let's look inside. Oof, it's heavy. All that iron is heavy, heavy, heavy. So now we see the reverse side of the circuit board. So I have worked on this, right? I took out the old and put in the new. Now, what I found when I worked on this the first time was that, I believe it was over here, there was a problem with the connection, and it was essentially dropping out half of the push-pull circuit. I figured the easiest way to fix the problem was just to use the new board, new components. Here we have a choke, and that is part of the power supply. So power is coming in here. All right, coming into the wall, through the wall, and through the power cord. On this side through a fuse, on this side through a switch. And we've got the black wires, those are the primary for the power transformer. And then we got all these other wires coming off that are on the secondary. So we've got these wires here that are heater wires. So that's a 6.3 volts AC circuit. And over here, a second one for the other half of the amp. These would essentially be like plate and screen voltages. This is an ultralinear wired amp, and I just don't know offhand which is which, but one of these is, they're going to be different taps on the high voltage, and over here too. Same here and here. Those aren't power. Those are going to the output transformers, which are through there and there. And then the sound comes out here and here. This capacitor is for the main power supply. I replaced this resistor and this resistor because those were, one of them was barely in spec, maybe, and the other, why not just go ahead and replace those? Those get a lot of work over the years. This is one of the negative supply, and then one of these is the other, and then the other is ground, I think. Here's our negative voltage with our diode here, and then that the other side of that has these capacitors and one or two dropping resistors. This has been added by somebody. It's not in the original schematic. It's supplementing these, which are to adjust the bias. And you can see some various other components that aren't on the circuit board. These are grounding, these are 470K resistors to ground from the inputs. These are output sockets or preamp power sockets or something like that. You could hook the Dynaco preamp up to this through these sockets. And we see all the various tube sockets. I redid the heater wiring, making sure these were all tightly wound, and running the heater wires across the socket rather than around it. Putting the wire around it makes a big loop. These have AC in them, so that's why they're twisted, so the AC will cancel itself. But you also don't want big old loops of it, so I'm trying to keep these wires close together and even still wound, twisted across the socket where I can. And so then we come to here, and then this goes to the heaters on the tubes on the board. And similarly over here. These are interesting little buggers. These are 15.6 ohm precision resistors. These are on the cathode, from the cathode to ground. They are essentially sense resistors so that you can look at the voltage across these and thereby figure out what the current through the tube is. So these pots are adjusting the negative bias voltage, but you're using as a guide how much current is going through this resistor and this resistor. These resistors bring up a thing that's pretty common with old tube amps, and I would do differently, and I may do differently. I may modify this. You see where it just goes to this lug here on the socket, similarly over here. The main ground for both signal and power is right here and here. Generally, you want to have all your grounds connected to the same spot. You don't want to be just grounding to the chassis. Now, it's not an awful practice, but it can lead to ground loop hum. And if that becomes a problem, then this is a problem. If you look at the later revisions of this amp, they just use bigger value capacitors. So I would use a bigger value capacitor. The other thing I would like to do for this is use Dave Gillespie's enhanced fixed bias. that will basically allow you to get more power out of this amp and make it sound better. Enhanced Fixed Bias does use a regulator. I would also like to use a regulator on the power to the 7199s. That will reduce the noise floor. That will reduce any hum that you're otherwise going to get due to ripple remaining on those power supplies. It's not a worry with the push-pull output stage because it's push-pull, and so hum cancels. But it doesn't cancel to the small tubes. And so there, it's a good idea to use a regulator. Now, of course, they wouldn't have used a regulator in the original design because this was designed before solid state was a thing. Well, not entirely, because it does have a diode. I think originally that probably would have been a selenium diode, though. I put in these new terminal strips here and here to have something to hook the feedback network through. So this is the 16 ohm tap on the output transformer. Previously it had literally just been twisted with this red wire and wrapped with electrical tape. Don't ever use electrical tape to make a connection in an electronic device. Bad, bad, bad. No, never. Not okay. I mean, it's not a horrible thing to have electrical tape in there, but the wires weren't even soldered together. Bad, bad, bad. Now they are secured to terminal lugs here and here. The other weird thing is that the 4 ohm tap, the brown wire, was the one that was connected to the outputs here. And so I've disconnected those and snipped them so they don't, cause trouble, and connected the 8 ohm taps, which is the way you would generally do it. Unless you wanted to wire this to run with 4 ohm speakers, in which case, yeah, of course, you would use these. Now, were you to do that, the original would have had a set of, 4 jacks, screw terminals out here. 0, 4, 8, and 16 ohms. Now we've just got 0 and 8. Okay. I think that's all I really need to point out under here. Here's our on-off switch. Here's our inputs. I need some hardware for that. Or I do kind of actually want to replace those. Problem potentially is that there's not a lot of room here. I don't know if there is room for 2 modern RCA jacks. There we go, that's 38 watts out of the right channel. And you can see clips. Asymmetric crossover distortion. Don't know if that's something I need to worry about. Right now I won't. I'll check the other channel though. Both channels fed, both channels probed. Channel at the bottom, clipping a bit before the other channel. We do also have 2 very different sets of tubes that needed to be biased pretty differently, so I'm not too awfully surprised. See how ugly it gets, how quickly. In any case, it is very good news, very, very good. Look at the backlit circuit board. I found some random screws to affix the bottom and top so that it can be easily moved about and appreciated. And having done the bench test, it is now time to listen. So it is time to fire it up. Wow. That was dramatic. And now we are going to listen We're going to listen to the most popular tube amp ever sold.
Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. Right before your eyes, feel the laughter from the skies. And it lasts till you cry.
So a couple of notes about it. I had trouble biasing the tubes initially. I was able to bias the Horizon tubes without any problem, but the old tubes I couldn't get to bias. They needed less voltage difference between cathode and grid. Somebody had put a 5.6K resistor in place of a 10K dropping resistor, so that left not enough adjustment with the bias pot to get it biased correctly. So I replaced that 5.6K resistor that somebody put in there with a half watt 10K resistor. Now, half watt, what the? Initially I thought, well, I really ought to have something more with a higher power rating. But I looked at the Series 2 schematic and it has that resistor in it, and it's just a normal resistor. So, yeah. I also calculated what the power dissipation would be for that resistor, for that 10K resistor, and it was much less than half a watt. So, half a watt it is. Maybe I'll replace it someday, maybe not. And like I said, after that, I was able to bias both sets of tubes without an issue.